So basically, review, addition, subtraction, rational numbers. Recall the steps for adding, subtracting rational numbers, so fractions. Determine the lowest common denominator, LCD, for the rational numbers. Express each rational number as an equivalent rational number with the same common denominator. This is just walking you through common denominator steps. Combine the rational numbers by adding, subtracting numerators, and then reduce to lowest terms if possible. So this is your steps for doing common denominator. Okay. So just a little quick review here with just actual fractions, nothing difficult yet. So first thing you want to check is you want to see does 3 go into 5. If it does not, then you multiply them by each other. Okay? So if multiply them by each other, what I mean is that you're going to multiply 2/3 by 5 on top and bottom, and 2/5 by 3 by top and bottom. Okay? I know this is basic, and you've probably done this a million times, but it's good to see again. So this gives me, Jesus, really wants to be lost. This gives me 10, okay, over 15. And notice 2/3 is equivalent to 10 over 15. That should happen every time. We're not changing the value. That's very important. Okay? And this side would be plus 6 over 15. Now that we have a common denominator, we can add the numerators. The top, 10 over 15 plus 6 over 15 is 16 over 15. And so that is as simple as it gets. You can write as a mixed number if you want, but that's not as useful in terms of solve. Like in terms of 16 over 15 is a better way of having it when it comes to math. Mixed numbers make things a little difficult in your calculator. Okay. Okay, so 5 over 6, 6 and 1 over 4. So these, again, 6 doesn't go into 4, 4 doesn't go into 6, so it doesn't really help me too much there. So I'm going to go ahead and multiply them by each other again. Now this one you could, what does 6 and 4 both go into? 24. Yeah, 24, but what about one lower? 12. 18 is not good for 4, but yeah, but 12. So you could do 12 if you wanted for your lowest common factor. It's a little bit easier if you just multiply them by each other, but the problem is if you do that every time, then like here, it's going to get pretty big, right? Right, and you have to really simplify. So it's kind of up to you how you do it. I don't care which one. I would just say when it comes to 3, it's good to get 3 that have a common meeting spot, okay? Because if you multiply by all 3, it's going to be very big. It's not too bad here. It's not a big deal. If you go 6 here, it's fine. If you go 4 here, it's fine. But then like Nolan said, you're going to end up having to simplify. So 4 times 5 is 20 over 24 minus 6 over 24. That gives me 14 over 24, okay, which can be simplified to 7/12. So you can see we got to 12ths like we thought we might. Okay. All right. Excuse me. So the third one, what do you guys think 8, 3, and 12 all get into? Yeah, 24. So we're going to get all these at 24. So we're going to times this by 3, top and bottom, this by 8, top and bottom, this by 2, top and bottom, to get them all to 24. So we got 3 times 7, 21, over 24, minus 16 over 24, plus 10 over 24. And now we're just going to go ahead and add and subtract those. 21 minus 16 is 5, plus 10 is 15. 15 over 24 can be simplified. 3 goes into both those numbers. It's going to be 5 over 8. Good. So 5/8 is that simplified answer. Okay. So the method for adding, subtracting rational expressions is identical to the method described that we just did for rational numbers. Identical in the sense you have to have a common denominator, then you add the numerators, and you simplify when you can. Okay. The restrictions are the same. They come from the beginning again. Okay, but like this case, is there any restrictions on these ones? There's no restrictions on these ones because why? There's no variables in the bottom, right? Denominators are a problem. Dividing by 0 is our problem. So that's what you're looking for. So in terms of these ones, we are simply doing the same math we just did, but we have variables in the numerator, and that's not a big deal. We're just going to combine like terms. So like for this one, hopefully you guys understand that 4, 5, and 10 all go to 20. So I'm going to go times 2, times 2, times 5, times 5, times 4, times 4. So I have 20 for my denominator. So that gives me 15x over 20 plus 4x over 20 minus 14x over 20. And so you see the numerator is all x's in this case. And if it wasn't, like let's say one was just a 4, not a 4x, then you just write it like, 6x minus 4. That's fine. But in this case, we do have all x's. So it's just 15 plus 4 is 19. Minus 14 is 5. So we get 5x over 20. Am I done? No, I can still reduce, right? The 5 over 20 is x over 4. X over 4 is the simplest way you can write that. Okay. What's nice about B? You don't have to do one of them. 3 goes into 6. I don't have to do anything in the 6. I can times this one by 2 and call it good. Now careful. So I'm doing that one by 2. I do have to distribute. It doesn't go just to the A. It goes to both of them. So this new one is going to be 6a minus 2 over 6 plus 4a plus 5 over 6. Now this we got combined like terms. 6a plus 4a is 10a. Negative 2 plus 5 is 3. And that's the only thing I can do. Now, you could break it up. I'm not going to, just because it doesn't go in evenly. So I'm just going to leave it like that. It's fine. I'd probably only document a test if let's say this was a 6. Then you can go to both, right? Like in terms of B. Well, actually, no, I wouldn't do that one either. The 3 is really making things hard because the 3 is smaller. Because that's 1/2. Yeah, like if this if this was a 6 and this is a 12a, then it would be 2a plus 1. Yeah, and that's cool. But when it's like this, you can leave just like that's fine. But if you do reduce it, like if you want to break it up, just if you guys want to see it, it would be this right here over this right here. So it would be 10a over 6, which would be 5 over 3, 5a over 3 plus 1/2 is if you wanted to break it up. But like I said, you don't have to. Okay, so this one, 3 and 8 have to multiply by 8 and by 3 in this case. So here we go. We're going to distribute that. 24y minus 9 is the top of this one. It's over 24. Minus, remember distribute, 16y plus 8 over 24. Now it's important when you're minusing, it's minusing both things. So it's minusing 16y and it's minusing 8. So what you have is to simplify, you have 24 minus 16, so I have 8y. I have negative 9 minus 8, so I have minus 17. And you can just leave it like that. All right. Any other questions there? Okay, so let's get to we're getting kind of working our way up a little bit harder here. Okay. All right, so this one, these two. So these two, one thing they have to throw at you is they give you whole numbers. And so the whole numbers you have to understand are all over what? 1. So just write those so you can figure out, okay. And then now, this case for the 1 in A, 2 and 1 go into 8, so we can just meet at 8. So that means I want you to multiply this by 4 and this by 8. So that gives me 28x plus 12 over 8 plus 24x over 8. It's a minus, sorry. Minus x minus 3 over 8. All right. So we have 28 plus 24 is 52. Minus 1 is 51. So 51x, what I have for my x's. 12 minus a negative 3 is plus 3, so 15 all over 8. Okay, just a lot of simplifying. Okay, this one's got double negative sign, so that's going to be something we're going to make sure we watch out for. 3 does go into 9, and 1 goes into 9, so we can all meet at 9. So 3 9, 9. So that means I'm going to have 36 over 9 minus y minus 4 over 9 minus 15 minus 9y all over 9. So I have it written all the way out now. So I have a negative y and a positive 9y. See that? Minus a y minus a negative 9, so it's plus 9. So that means I have 8y for my y's. Okay, I'll say that again. I have a minus y and a minus a negative 9y. You can. I just like to do my variables first. But you can. So then here, 36 minus a negative 4, so that's 40. Minus 15 is 25. So 25 is your constant over 9. Okay, just watch for your negative signs there. Sometimes some people like to put the brackets. They think that helps them. You can if you want. It's fine. Okay. Now we're going to take a step back to a little bit easier where they already have a common denominator, and then we're going to go to a binomial bottom, which makes things a little bit harder. Okay. So here, they all have common denominators, but we also have variables in the bottom now. So we have variables at the bottom, we have non-permissibles. We have things we can't have. Okay. So remember, whenever your trigger goes off, okay, I got an x in the bottom, that means there's a chance there could be a non-permissible. Okay, so we want to watch out for those. So for example, a is non-permissible is what? 0, yeah, x can't be 0. Let's just do these first. Let's do non-permissibles for all of them first. B's is negative 2 times 2 is negative 4. Still 0, yeah. Because 2 times what is 0? 0. Right? A little bit silly. This one. Just 1/3, not 0. Because 0 now gets me negative 1, right? Yeah. Oh, the top. Yeah, the top's okay to get 0. Okay, so this one's 1/3. If you're not sure how we're getting that, if you're not following, add the 1, divide the 3. We're figuring out what makes this 0. So guys, in reality, if you're really confused on how to find non-permissibles, take the bottom, set equal to 0. Oh, that's solved for x. I'm done. Take the bottom, solve for 0. Divide 2, divide 2. Oh, okay, 0. Right? This one, take the bottom, set equal to 0. Add the 1, divide the 3. That's where this comes from. Okay? Some of us are just a little bit quicker on our mental math that we just kind of see those answers. Then so for x plus 3, x can't be negative 3. Okay? All right, so 2 plus 7 minus 1, so that's 9 minus 1. I get 8 over x for this one. Remember, we don't have to do any common denominators. They all have one, so it makes it nice. This one, 5a plus a is 6a. 3 plus a negative 6 is negative 3. So this one you could pull a 3 out if you'd like. It doesn't really take you anywhere here, so you don't have to. But if you left it as, that's fine too, I guess. Okay, this one here. Interesting, what happens here? Yeah, so what's that mean? Yeah, it means it's equal to 1. Same over same. 3y minus 1 over 3y minus 1. This one, 4 minus 2, 2x. 10 minus 4, 6. So this one, it does help to simplify it. A positive 6, thank you, yep. And so I pull a 2 out, it gives me an x plus 3. So this one is 2, fully simplified. Three more examples left, example sections. So now for these ones, they're not common. So then what would you do? I would tell you, focus on what do you need. Okay, so like for example, these both have a p, so don't worry about the p, they're already there. Okay, what's different is the 3 and the 7. So we're simply going to go by 3, by 3, by 7, by 7. That'll give me 21p on the bottom for both. Okay, so a lot of people get a little bit hung up on they multiply by 3p and 7p to each other. But that gives you an extra p that you don't need. Okay, so don't do that. All right, so in this case, this is going to give me 35 over 21p plus 6 over 21p. So we get 41 over 21p. What's the non-permissible? Yeah, p can't be 0. So then what I said about a, now let's look at b. The 6 over 5 is missing a y. Right, so we need to multiply it by 3y this time. And this time just a 5. So we get 5 over 15y, and we get 18y over 15y. And so you see what happens is that changes my terms on the top, because they were like terms, now they're not. That's okay, we'll still write them next to each other, but we just can't combine them, right? That's as far as we can go. We just leave it like that. In this case again, y can't be 0. For your non-permissible. Any questions, guys? It's a quiet group today. We're out for Halloween already? Okay, C, 6x, 3x. Nice thing there is 3x, I can make a 6x pretty quickly. Okay, just timesing it by 2. If I just times this by 2, times this by 2. Okay, so we got 2x minus 5 over 6x minus, distribute that, gives me 6x minus 4. So 2x minus 6x, negative 4x. Negative 5 minus a negative 4 means plus 4, so negative 1 all over 6x. So in this case, still, x can't be 0 for your non-permissible. That's all so far. All right, and this last one really ties it all together before we go into binomials on the bottom. Binomials is where it's going to get messier. It's where I'm telling you this section is all about organization. Okay, so the next section I've been talking about, but these ones aren't too bad. So this one, one's a squared and one's a, so we immediately know that this one here needs an a. And then we'll just go ahead and go by 2a. Then what do you times this one by? Just 5. Good. Okay, so my common denominator for this one's 10a squared. Okay, so top left, 5a plus 35 over 10a squared. On the right here, minus 6a over 10a squared. 5 minus 6, negative a, plus 35, all over 10a squared. And that would be it. Again, this is again the one where a can't be 0. Okay, any questions at all? Okay. I'll just pause it for a second here. All right, so but yeah, don't answer that. All right, so this one here, we got 2x and x minus 4. Again, just concentrate on the bottom. The bottom, we need to get the same. So yes, on this one, unfortunately, we have to go 2x, and we have to go x minus 4, x minus 4. And what makes that difficult is, yeah, we do have to FOIL that. Okay, so we're going to have to FOIL that top left. Yeah, so this is where it gets a little bit more difficult. Well, look at all this room here. Okay, so the top left. Now, one thing I would tell you, don't FOIL or multiply the bottom out. Leave the bottom factored. Okay? Right, because you can see your non-permissibles easier, and you can see if something happens to cancel later. Okay? because what you'll do is you'll want to refactor it later. We don't want to do that, okay? Because these are staying the same, right? So yeah, leave the bottoms like that. That'll make your work a little easier. So the top is x squared minus 13x plus 36. And then it's 2x times x minus 4 in the bottom there, plus 6x squared over 2x times x minus 4. And so now that we're good, we can just combine like terms. It's simply going to be 7x squared minus 13x plus 36 all over 2x times x minus 4. That's your simplified rational expression. Yeah, it's a lot of busy work. That's why I keep pushing organization for this section. Non-permissibles are x can't be 0 or 4. 0 from here, 4 from there. So 0 comes from that one, 4 comes from that one. Okay, any questions on that? Yep. What's up? In this case, we always do non-permissible before we do any canceling. We don't do any canceling, so doing the beginning or the end, it doesn't matter. So like, do you see it came from these two? So you can do it in the beginning too. Yeah. The only thing too, Emily, is that you want to make sure that you don't, when you cancel, don't not count that non-permissible. That's still non-permissible when you cancel. Yeah. Maybe. It's pretty big, but in this case, I don't think you can. 7 times 36, 210, 252. So factors of 252 are 13 apart. I don't think there is one.
So we can just leave it at that.
Right, for this one you can. Yeah. There is one. I think there is one here in a second that we will be able to factor a little bit, but yeah, the one on at the end. But yeah, for these ones right now, Joel, like especially like this, that's fine. What's one way, guys? Let's go and use our unit 3. Let's just kind of reconnect everything. Let's go off track a little bit here. How could I see if that one is factorable? Quadratic formula or the discriminant, right? I can do the discriminant and see, oh, there is 2 solutions, right? And then once you get the discriminant, you'll see like whatever that number is. If it's a nice smooth number, then it's going to be whole. If not, it's going to be decimal. If it's decimal, that means we're not going to be able to factor it because it's going to be a rational number. So if that's the case, then you just leave like that. Nothing's going to cancel is my point. Because these right here to cancel. The only thing I could cancel would be these 2. Well, 0 is not going to cancel from here, right? The only chance is there's an x minus 4 in there. Right. So let's just do that just for fun here. B squared minus 4ac. So we're talking about discriminant from unit 3. We're tying it together to see how many solutions, okay? Might as well. It's on your midterm, discriminant is. So b squared, negative 13 squared, 169, minus 4 times 7 times 36. Can somebody help me with that? Actually, you don't need to. That's going to be way bigger. So it's going to be negative, which means there is no solutions there. That is not factorable. Okay? What's that? Right, no, it's the thing that tells you 2 solutions, 1 solution, or no solutions. Okay? All right, a little off track, but a good point. All right, so here we go. This one, now you see we have to do binomial, binomial. They gave you nice tops, though. Okay? So when we do that, we get 4y minus 12 on the top there. Remember, don't FOIL the bottom out. Minus in order, these doesn't matter. If you put y minus 3 first, that's fine. So 4y minus 2y is 2y. Negative 12 minus 5 is negative 17. And that's it. Okay, you have to do non-permissibles. We'll do that in a second. So y can't be 3. That comes from here. And what's this one? Negative 5 halves. Okay. Okay, and this one, next one's going to not be as fun because why? Do you see why? Well, because we're going to have binomials top on both top and so like when I do x plus 1 here, that's a FOIL. X minus 5, I got a FOIL. X plus 1 here, I got a FOIL. I'm going to FOIL twice on the tops. So I'm going to go ahead and lose this writing if you need it, or so we can finish it. I'll just start it. So what I'm saying is, oh, we should have room actually. This is going to be an x minus 5, so FOIL the top, x plus 1, FOIL the top. What's that? Yeah, leave the bottom not foiled, yep. Okay, so top left is going to be 2x squared, x, 2x, 3x, and 1. And what I do too is a little shortcut, and I'll share with you guys. I'm fine if you do this. Like right now, I know I have work to do, but I know the bottom is the same. You can just put like italics here, just saying I know what's down here. You don't have to keep writing it every time, just to save yourself some work, because it stays the same, right? We're not changing that bottom. Especially on the harder ones, you can do that. Okay, and then this one here is going to be x squared minus 9x plus 20. Okay. And now we can just do that work on the top. 2x squared minus 1x squared is 1x squared. 3x minus a negative 9x means plus, that's 12x. 1 minus 20 is negative 19. And so this one, 19 is a prime number, so it's not factorable. Okay, so that's when you can rule that one out, and then you're done. Non-permissibles, 5, negative 1. Okay, oh wait, 5, what are we talking about? No, that's right. Yeah, the work on this one's wrong. Okay. Yeah, it's a 5. It's an awful 5, yeah. 5, negative 1. All right, we got one more problem. Okay, here we go. So, 3. So it's got 3, which isn't too awesome. But this one, you have to do them all by each other. So this one gets ugly. Yeah, so I have to, except for there's nothing up here, so it's actually going to be FOIL. But yeah. So the x needs x plus 2, x plus 1. Yeah. Okay. The x plus 1 needs x and x plus 2. Okay, the top and bottom. The x plus 2 needs x and x plus 1. Okay, so you see everything just gets hit by the other 2. Now your bottom, we don't have to keep writing, but your bottom is going to be this. That's your bottom, right? Just those 3. Okay, I'll pause it here, let you catch up. Yeah. Okay, so as we were just talking about, really only have to FOIL once, just this guy. That's all I have to FOIL. Okay, so let's just go minus. We know what's down here, plus. We know what's down here. So what I'm doing is I'm just setting up, I have my 3 sections. 1, 2, 3. So it's 1, 2, 3. And so I'm going to simplify the tops there. So the top for the first section is going to be 3 times x, which is 3x, times x plus 1. So it's 3x times x for 3x squared, 3x times 1 for 3x. So the top left, the first section is 3x squared plus 3x. So 3 times x, and then these 2, they go to the x here. Yeah. They distribute in. So the second piece, the middle one, it's going to be 2 times x for 2x. So this 2 and this x, and then 2x times x for 2x squared, 2x times 2 for 4x. So that's there. Remember, it's minusing that group. So when you do minus, make sure it's minusing the whole thing there. third and final section we do have to FOIL. It FOILs out to be x squared. The 1 doesn't do anything, right? X squared plus 3x plus 2. And now we just combine like terms on the top. That's it. So your answer, 3x squared minus 2x squared is 1x squared, plus 1 is 2. So I got 2x squared. So my x squareds are done. Let's cross those off. 3x minus 4x is negative x, plus 3x is 2x. Okay, let's cross my x's off. And then just plus 2. So they'll have a 2 in common. Let's just pull a 2 out, just to see if that does anything. So it's give me 2. Okay, and then it doesn't because that's not factorable. Okay, because there's no combinations of 1 that get me 1. So that's as far as you can go. So your non-permissibles are, 0, -1, -2. All right.